Okay, so the final method that we're going to learn for solving systems is called linear combination. Well, actually it's called linear combination / elimination. And this one is, I'm going to be honest with you, it is by far the weirdest method. But it works. So I can't exactly explain to you why it works. But I promise you that it does. I'm sure there's a video out there that explains it perfectly, but I only got 5 minutes. So I don't have the time to explain it. We'll talk about it. I'll try to see if I can find something that explains it. But it might be more trouble than it's worth. Okay, so what we do with linear combination is we're going to combine. Combine means to add. Linear combination means to add two linear equations. So we're going to add these linear equations in a way that we eliminate one of the variables. Remember, the point is for us to get this down. We use these two variables, these two equations, to create a new equation that only has one variable. So we can solve it and figure out what the other one is, okay? So the point is that we're going to try and force a zero pair. So you see right here I have a zero pair. I don't have to force the zero pair. It's right there. I'm going to show you how to do the process with this one, and then I'm going to do a harder example that shows you how to actually create the zero pair, okay? So linear combination says that I'm going to force a zero pair. I already have a zero pair here. And then I'm going to add the two equations together. So what that means is I'm going to add the x's, I'm going to add the y's, I'm going to add the numbers. And what I want is I want to wind up with a zero, with one of my variables being eliminated. Okay? So if I add these together, 2 plus 3 is 5x. -1 and +1 makes a zero pair. So this whole y variable zeroed away when I used elimination. 4 plus 6 is 10. So I add everything together, okay? So 5x equals 10. Well, I don't care about 5x's. I want to know what 1x is. So I divide both sides by 5, and I get x equals 2. At this point, the process is largely the same as the other ones. I take this x equals 2, and I plug it back into one of my equations. I have 2x minus y equals 4. So I'm going to put my x there. So 2 times 2 minus y equals 4. 2 times 2 is 4 minus y equals 4. If I subtract 4 from both sides, I get -y equals 0. Okay, and when I flip that, there's no such thing as -0, so y equals 0. I think x is 2 and y is 0. I'm going to use my remaining equation to prove it. 3x plus y equals 6. Well, x is 2. 3 times 2 plus 0 equals 6. Well, 6 plus 0 equals 6. That's true. Okay? So I was able to use linear combination and prove that my coordinate is 2, 0. That is the solution to this system. Okay? Now let me show you. So that was the actual process of using linear combination. Now, it's not always that easy because sometimes you have an equation like this. So this equation that I gave you, you already had a zero pair. But what if you don't have a zero pair? Then we're going to force a zero pair. Okay? So we're going to look for terms that will easily cancel because their coefficients are opposites. Now, 3y and -2y aren't opposite, like they're not a zero pair, but they are opposite signs. Now, you could use any of these. So like I could do like 3 times 2 is 6, -2 times 3 is -6, then I got a zero pair. I could do 2 times 5 is 10, -2 times 5 is -10. So, and what I'm going to do is I'm going to multiply the entire row. The entire row by something that creates a zero pair. Okay? So, if I take this entire row and I multiply it by 2, I have 4x plus 6y equals -2. Okay? I didn't multiply by 6, I'm sorry. I multiplied by 2 to create 6y. Okay? Now, if I multiply this entire row by 3, 3 times 5 is 15x. 3 times -2 is -6y. 3 times -12 equals -36. I have created a zero pair, and that's what I want. I forced terms to become opposites so that I could eliminate something. Okay? So I started by looking for terms that would easily cancel. I didn't find any. I didn't find like a 3 and a negative 3 or a 2 and a negative 2. But I'm going to look for something I can multiply both sides by that will force a zero pair. So I was able to force a zero pair here by multiplying the top row by 3 and the 2 and the bottom row by 3. And again, as long as I multiply everything by the same number, I'm scaling it up and it's okay. All right? So now I'm going to do that same process. My y's zero out. 14 plus 4 plus 15 is 19x equals negative 2 and negative 36 is negative 38. When I divide both sides by 19, I get x equals negative 2. And then I do the same thing I've always done, which is I plug into the first one, I check with the second one. So 2x plus 3y equals negative 1. 2 times negative 2 plus 3y equals negative 1. Negative 4 plus 3y equals negative 1. 3y equals 3. And so I think y equals 1. So I think x is negative 2 and y equals 1. So I'm going to use my last equation, 5x minus 2y equals negative 12, to prove it. Well, if x is negative 2 and y is 1, that should be true. Well, 5 times negative 2 is negative 10. Negative 2 times 1 is negative 2. Negative 10 minus 2 is negative 12. And that's correct. So my answer is negative 2, 1. We will practice this a ton more in class tomorrow.